So this video is with regards to the introduction of matrices. Introduction to matrices. A matrix can be considered as a set of numbers arranged in rows and columns in rectangular form and is encapsulated within a pair of brackets, curved brackets. The numbers are called the elements or entries of the matrix. So the size is expressed by first stating the row, then the word by, and then the column. Okay, so R for row and column for, and C for column. So you can say a 3 by R by column. Okay, R by C. So for example, here you've got a matrix, and it's got two elements, 2, 4, -7, and 5. Okay, so because it has two rows, the 2 and the 4 constitutes a row, and the -7 and the 5 constitute a second row, and the 2 and the -7 constitutes the first row, and the 4 and the 5 constitute the second column, sorry, column. So it can be considered a 2 by 2. Okay. Here you have -3, -5, 3, that's a first row, 7, -8, second row, 4, 1, third row, but -5, 7, and 4, okay, that's one column, 3, -8, and 1, that's another column. So that's considered about 3 by 2, 1, 2, 3 rows and 2 columns, a 3 by 2. Similarly, this one is considered a 2 by 3, 2 rows and 3 columns. This one is considered a 3 by 1. So each element there can be considered a row. The 6, the 0, and the 4 constitute 3 rows, and vertically downwards, they all can be considered as constituting one column. So that's a 3 by 1. Here now you've got a 1 by 2. Okay, so the 9 can be considered a column. The -3 can be considered another column, but together they form a row. So that's a 1 by 2. Now let's talk about the position of the element in the matrix. So in order to describe the position of an element, you must first mention the row it occupies, then the column. Okay, for example, element A is in the row R and column C. So for example, this element here, this matrix actually is a 3 by 3, 3 rows, 1, 2, 3, and 3 columns, 1, 2, 3. So this element here occupies the position 1, 1, meaning it's in the first row and first column. This element here is in the second row and third column. Okay, as you can see, row number 2 and column number 3. This one here is in the third row, 1, 2, 3, and column number 2. Now let's move on to talk about the operations, the properties, and the applications in algebra. So the operations in matrices will be addition, subtraction, multiplication. There is division, but is like inverse multiplication. We'll see what that means. Then the properties are the determinant. You've got singular matrix, the adjoint matrix, transpose, inverse. So these words will be considered, will come along, will pop out anytime when you are doing a matrix, a problem involving matrix. The determinant, the singular matrix, adjoint matrix, transpose matrix, the inverse of matrix, example. And then you have application in algebra. It is very common to solve a pair of simultaneous linear equations using matrices. And to stress the importance of solving a pair of simultaneous equations using matrices, let's take a look at the January 2024 paper 2. So here's the cover page, January 24, 2024 paper 2. And let's go to question number 10. And as you can see, the question says to solve the following pair of simultaneous equations using a matrix method. So this question is mandating that you apply matrices to solve this pair of simultaneous linear equation.